Hello everyone, and in this video today I would like to look at something called the vector method. This particular question is really universally applicable. It could be on GCSE, it could be on IGCSE, it could be on A level. So it's really across all of those. This actual question could appear on any of those. Now, let's have a look at the question. It says OAB is a triangle. Q is the point on AB such that OQP is a straight line. O to A is 4A, O to B is 6B, and A to P is 2A add 8B. Use a vector method to find the ratio of A to Q to B. Now, because of the way that they're asking for the ratio of A to Q to B, what I think is going to be really helpful is if we find two different routes that go from A to Q. And it's absolutely essential in this method that we pick two different routes, both of which should use different kind of diagonals or like totally different paths. So to get there. Okay, so like for example, what I'm saying is in this one, I'm going to find one route from A to Q that is just directly going there from A to Q. And then my other route I'm going to choose is going to be from A to O, and then I'm going to make use of this line here. And it's essential that I should have one route that makes use of this line and one route that makes use of this line, okay? If you just have two different routes that kind of like only involve different ways of going around the same path, then you often end up with the unfortunate result of finding out like 5 equals 5 or something like that. So you need to get two different routes starting and finishing at the same point. And I've chosen to have it doesn't really matter what that starting and finishing point are either, but I've just chosen A to Q because of the fact that that's going to directly help me to have then part of my answer for the ratio of A to Q to B. So first of all, let's have a look at my first route. My first route I'm going to say is just to go from A to Q directly. So A to Q directly there is going to be some fraction lambda, which I don't know what it is, of A to B. So then I look at my diagram, I say, okay, then what is A to B? And A to B is going to be A to O plus O to B. Okay, so that is going to be A to O plus O to B, which is going to be minus 4A add 6B. So minus 4A add 6B. So I've got lambda times that. And I'm going to expand the brackets. So I'm going to get minus 4 lambda A and plus 6 lambda B. And that is my route for A to Q. Okay, so I'm going to park that result there now. Let's now look at my other route. For my other route, I'm going to go A to O, and then I'm going to go from O to Q. So my other route from A to Q is going to involve me going from A to O, and then I'm going to go from O to Q. Now, O to Q is some fraction of O to P. I'm going to call that mu of O to P. Okay, so I'm going to have A to O plus mu of O to P. Okay, now let's have a think about this. Now we need to think to ourselves, okay, so that's fine, but what is O to P? Well, to go from O to P, write this down here, O to P would be O to A plus A to P. And the reason I've written that down is because they've very helpfully given us A to P. And O to A is 4A. And A to P, we're told in the question, is 2A plus 8B. So bringing that together, that gives me 6A plus 8B is my O to P. Okay, that's perfect. So I now know what O to P is. So I'm going to take that result and put that back in my A to Q. Yep. So my A to Q is in this path A to O, which is going to be minus 4A, plus mu, some fraction, of O to P. And I've just found out that O to P is in fact 6A add 8B, 6A A add 8b. So just as I did before, I'm going to now expand that bracket, giving me minus 4a plus 6 mu a plus 8 mu b. Gather together my a terms and take the a out. That's going to give me 6 mu minus 4 times by a. So I've just gathered together this term and factorized out the a, plus 8 mu b is equal to my a to q. Okay, so now we've hit our critical juncture now. We've now found two different paths that go from a to q. So now what we do is, in the vector method, because these two paths are equivalent to each other, we can put them equal to each other. So we can now say that this path can be put equal to this path. So let's do that. So minus 4 lambda a plus 6 lambda b is in fact going to be equal to 6 mu minus 4 a plus 8 mu b. So we've just basically put those two different roots, both starting at a and both finishing at p, as being equal to each other. And now we use a really important technique called equating the coefficients. Now all that means is that whatever's written in front of the a on the left-hand side here is the same as what's written in front of the a on the right-hand side. So I can form an equation. So if I write down equate coefficients of a. So if I equate the coefficients of a, that means that 6 mu minus 4 is equal to minus 4 lambda. So that is an equation. I'm going to call that one equation 1. I'm now going to do the same thing. I'm now going to equate the coefficients of b this time. So this time, 8 mu b, so 8 mu is going to equal 6 lambda. And I'm going to call that equation 2. So I've taken 8 mu is equal to 6 lambda, and I put those two things equal to each other. Okay, perfect. Right, so now all that remains for us to do is to solve this pair of simultaneous equations now. So let's have a look at this one. Yes, we have got here. So let's think about how am I going to solve these? Well, I'm going to take equation 2, and equation 2 can be written as, let's just say mu. Oh, now I'll tell you what I'm going to do. I'm going to go back to thinking about my a to b, and I'm going to think, right, what was my vector that went down from a to b? It was lambda times ab. So back in the start here, I said that a to q was lambda of a to b. So I really want to find out the lambda so I can see how far it is, because that's going to help me answer the question. Okay, so I want to try and find, ultimately I probably could do with finding out what mu and lambda are. So I'm going to write that mu is equal to 6 lambda over 8, just from rearranging equation 2. So if I write down from equation 2, mu is equal to 6 lambda over 8. So mu is equal to 3 lambda over 4. Now I'm going to take this result, we call this equation 3, and I'm going to sub equation 3 into equation 1. Okay, so when I now sub equation 3 into equation 1, I've now got 6 mu, which is 3 lambda over 4, minus 4 is equal to minus 4 lambda. So I've just taken that value of mu and subbed it into equation 1, which was 6 mu minus 4 equals minus 4 lambda. Okay, that's going to look good now. So let's see what we get when we simplify this. Okay, so we are going to have, now 3 times by 6 divided by 4 is going to give me 18 over 4, which is going to be 9 over 2. Lambda minus 4 is equal to minus 4 lambda. I'm going to add that 4 lambda over here. So 9 over 2 lambda plus 4 lambda minus 4 equals 0. Add that 4 across to the other side. So that gives me 9 over 2 lambda plus 4 lambda equals 4. And then I'm going to do my 9 over 2, add my 4, which gives me 17 over 2. So 17 over 2 lambda is equal to 4. So therefore, I'm now going to say that lambda is equal to 4 times by 2 over 17. So I've just essentially divided by the 17 over 2 lambda, and I've done that by timesing by 2 and then divided by 17. So I'm now going to say I'm going to have 8 over 17. So I've got that my lambda is equal to 8 over 17. Now this is absolutely perfect, and this is going to really help me now because I've got to try and find the ratio. Now what this means is, let me just draw a quick sketch here. Here's our sketch of our situation. That's our A, that's our Q, and that's our B. That's our O, and that's our P. Now I've just found that the value of lambda, in other words, the fraction that I have to go down A to B to get to Q, I've just discovered that that is 8/17 of A to B, okay? So therefore, what that means is that means that this bit must be 9/17 to go from Q to B. So that means I can say, now I've answered the question now, that my ratio of A to B to, my ratio of A to Q, my ratio for A to Q to B is in fact 8/17 to 9/17, and I can times both sides of that ratio by 17, and that gives me that my ratio is in fact 8 to 9. And that is our question answered. Okay, so just to review the method, the vector method, which again is applicable to GCSE, IGCSE, and A-level. The route, the method in essence is to find two different routes that start and finish at the same point. And it's very important that they take two different paths. So you find your two different routes, two different paths, you put them equal to each other, and then you get a pair of simultaneous equations by equating the coefficients of A and B. You then solve those two simultaneously, which gives you your value of mu and lambda. And then once you've got your values of mu and lambda, that's going to help you to find out the ratio that you need to find. In this case, I only needed to find the lambda. I could, of course, gone on to find the mu. I would just need to say that mu is equal to 3/4 of lambda from our equation before. So I could say that mu is equal to 3/4 times by 8/17 if I needed to find out what the mu was. So if I was just to quickly do that, times by 8/17, let's just do that now. Okay, which would be 6/17. So if I needed to find it, which I didn't for this question, but mu would have been just 6/17, which I found out by using the equation that mu is 3/4 of lambda. And we found that lambda was 8/17. So therefore, if I needed the mu, it's quite easy to find that as well, but I didn't need it for this question. Okay, I hope that you found that useful, and I will see you in the next video.